This is Vintage Electronics Geek, and today we are going to, do I dare say, service, restore, refinish, refresh this Heathkit T-3 signal tracer. So I do apologize on the title. The title may be misleading. I really don't know what to label it. The device does work. However, it does need to be refreshened, and that's what this video is going to be all about. Need to get in there and replace components that need replaced, and then we are going to do that as well. These devices came out in 1958, and they sold for $23.50, and that did include the probe. However, if you wanted to buy the probe just by itself, that would have cost you $3.50. Now, that's not what I paid for it in today's money. As you may know, if you've ever priced these, they can be rather spendy. No matter how simple a device, they can go for crazy, crazy money. I bought this device through an electronics recycler that I frequent. He generally gives me a fantastic deal, and I buy a lot of stuff from him when I go to visit, which is not often, as I would like. On this particular day, I spent about $350 with him, and of course, everything, you know, he'd give me a price and I'd Jew him down, and he'd say, okay. Well, I figured on this device right here, he wanted $75. I figured, well, you know, he's giving me a deal on everything else, so why not pay full asking price for it? Well, that was the thought anyway. I offered $70. He took it. So I don't mind. I would have probably talked him down more, you know, in general, but like I said, he's done me good, and I just kind of sort of returning the favor. This device I bought separately off of eBay, and I paid $40 for that device. Again, not really what I wanted to pay, but these things aren't cheap anymore. So before we move this out of the way, what we're going to do with this, we're going to go through it, and at the end we're going to test it, check out the components. I have not tested it. I do not know if it works. I think it does, but I don't know. And then I need to put a new end on this, a BNC connector. On this device, we're going to go through and replace all the needed components, electrolytics for sure. I have since ordered the electrolytics that I needed, and then some more. We're going to replace these jacks out with BNCs. I originally thought about just leaving them stock, but then I thought, well, you know, I need functionality more than I need a shelf queen. So I'm going to replace them as opposed to leave them stock. These switches are very, very hard to switch. So I'm going to go in here and put some penetrating oil on it, see if it'll break free without having to replace them. If I do need to replace them, then I will. This knob here is put on incorrectly. That's the far left that it goes, and then the far right, a little off. This knob is kind of sort of in place. This does work. Don't know about this section. I haven't tested this section. When I bought it, he said that it did work. We went to his bench and we opened it up, and I looked at it and I saw that it was all original, and went ahead and plugged it in right there. And once I saw that it did fire up and touched that and it made a noise, I went ahead and committed to buying it. The case is in really good condition. When I'm all said and done with the project, I would like to go ahead and polish this all up and get it all cleaned up as nice as I plausibly can. It has the original AC mains cable on it. And as you can see, it is cracked. And it's not cracked just in this spot, but it's cracked throughout the entire cable. So I'll put a new AC mains cable on it. I do have some in stock. I'm not sure if I have a black one. I know for sure I've got a couple of whites, and I even have a purple. I don't think I'm putting a purple on this one. I'll put the white on first. But if I have a black in stock, then I'll put the black on in stock. Alright, let's go ahead and open the device up. Now to get in there, we just need to remove these two flathead screws. Now I want you to know that I really don't work on tube gear. Never really had well, I shouldn't say I never had a need to. I do have several pieces of gear, test gear as well as radios that are tube that I do need to eventually get to. And this screw is being a little stubborn. And I need to unravel the cord here. And if I remember right, it was kind of a challenge to open and put back together. And that it is. Dang, that is challenging. So I've had this for a while, and this is really the first chance I've had to get to it. It is a piece of test gear that will be used often or when needed. So inside the case, now on the YouTubes there are a plethora of videos that have to deal with this very same topic. My video's not going to be anything unique. Mr. Carlson, if you're familiar with him, he actually did a video, about an hour and a half long video, where he talks about doing a modification on this because these things are noisy. And I will be attempting to do that just the same. So you can see, pretty much all original. Not sure if this one might be new because it looks different. Let's see if there's a date on there. What? Now I have bad eyeballs. This is true. Okay. And what I thought I was reading turned out not to be what it was. I thought it said a dry battery cell. And I'm thinking, why would you put a battery cell in here? But it says dry electrolytic, and I can't make out the other word. I think maybe disposable, the bottom word down there. So even in the camera monitor, I cannot make it out. Maybe you can. Dry electrolytic disposable? I really don't know. Trying to see if I could spy a date on it, but I am not seeing a date on it. Either way, its days are numbered. Like I said, the iTube does work. The device does work. I don't know how weak or strong the tubes are. So before we get started on the project, let's go ahead and test the tubes. And that way, if they are bad and I don't have any in stock, which I have very few in stock, I can get those ordered. So we do have a electrolytic here as well. Yeah, very, very dry, stiff switches. So, all right, let me get my battery tester. No, my tube tester, and test these out. All right, got my tube tester out. I very infrequently use the device, and every time I do, I have to train myself on how to use it. But I think I'm getting better, so hopefully not too bad. Let's go ahead and grab our first tube. And so this is a 6x5, which is a full wave rectifier. I'm going to sound smart here, like I know exactly what I'm talking about and what they do, because I've got the manual open and it's telling me what they are. I couldn't tell you what these things were from Adam if I saw them on the street. However, I have learned that the first digit represents the voltage that it takes to illuminate the elements. And this is a Sylvania. And it looks like it goes right here. Or does it? There we go. Pick a hole, any hole. I know it was in one of those holes. So now I need to get the manual, and look up 6x. What did I say? 6x5? Yeah. Or in my eyeballs, it's a 6x5. It's almost like a 6x9, but a little smaller. It's going to take me a moment to find what I'm looking for. I'll come right back. Okay, so a 6x5, we have two settings. So that's telling me that there's two sides to the tube. And really, my tube knowledge is not that much more above what I just spewed out there. So we need to put this on F, filaments on F, and the filament voltage is on F, and then clear those all out. So then number 2 needs to go to F. And then our plate goes to 3. Our load goes to 30. And that's it. So now we just turn this thing on. Let me bump you in closer. Oh. Don't need to bump in closer. You can see that thing. Holy moly. Look at that. Now that was cool. Let me double check my settings. D2, 3, and 30. Go to F. Yeah, settings are groovy, but I'm thinking I might have just blowed that thing up, eh? So that was leakage test. Let's turn it back on and see what happens. Nothing happens. Okay, fantastic. Blew that up. Let's go over here and check for shorts now. And so I think number 7 is going to be where the light will illuminate. Or it's going to be 3 and 5, I don't know. We'll find out. Something to do with number 7. Alright, fantastic. Blew that up, didn't we? Oh, crap. Darn it, you know what? My filament voltage. What am I? That should have been on D. Do you think it lives, or did I blow it up? I'm pretty confident I don't have one of these in my collection. Now I'm not into tubes. Couldn't begin to tell you if, since I blew the filament, should I still show leakage, or is this side of the test mute right now? I think it's mute, because if I blew that up, it's not allowing the voltage to go through, make a cycle. It's probably not going to work. So I might have just solved that riddle by myself. So, dead. We'll call that one dead. Now, I do know that there is a way you could ohm these things out. I'd have to get the schematic on it. I think you ohm out the filament and see if there's a short. But I'm not bright enough to tell you which pins otherwise. So we'll have to order that one, and it'll be my luck. That's going to be the expensive one. Put that back as a placeholder. And she's tight, I can tell you that much. Next one here is U.S. Army VT-134. Victor Tango 134. That is not, oh, here we go. That's better. 12A6. I was going to say that's not on my list. 12A6 is a beam power output, which I think is for my magic eyeball. Man, Wish I had a magic eyeball in my head, I could tell you that much for sure. This one's got a shield on it, so if I blow that one up, we're not going to be able to see it. And you see the meter climbing. So you're seeing it pretty much as it is in the display. It's probably at about a 48. It's in the question mark section. So still usable, but you know, if I had a stronger one put in there, okay, I would. I don't think to run right out and buy a new one is warranted at this moment. Actually, I may do it since I have to order the other one. Alright, so now let's go ahead and check for shorts. Oh, put it over there. Had that in the wrong place. Alright, so 7 is normal according to the guide for leakage. Okay, so that is all ducky. So this needs to go back to 5. And now let's go ahead and check for, is it emissions? Alright, so a little weaker. That's probably at about a 49. So I will probably pick one of those up as well. I can tell you one thing right now. At this point, so far, all the tube sockets very nice and tight. Alright, so here we have a RCA. This is a 12SH7. And that is a high gain pentoid amplifier. That needs to go to E. This needs to go to 2. 5 goes to neutral. Our plate goes to 4. 30. And for shorts, normal light indicator is going to be number 7. So let's go ahead and turn this on. And I apologize if that's in your way. Alright, so let's go ahead and clicky clicky. That's normal. Okay, so that all looks good. So let's stick our plate back to 4. And let's check for emissions. Oh, that's really, really good. That looks to be about a 70. Awesome. So we got one good tube for sure. Alright, the last tube we have here, Sylvania VT153 or SC199 Alpha. Which is not in my book. Not in the catalog, right? SC199. So the only one that's left that I haven't tested, 12C8, the amplifier and watt meter rectifier. Let me search this out real quick and see if it cross-references to what I'm supposed to have. Okay, after cross-referencing that tube, yes, that does come back to a 12C8 So that's the amplifier and watt meter rectifier, because that thing does have a watt meter on it. And while I was looking, I went ahead and price checked the tube that I blew up, and that's not too terribly expensive for a new one. So I'm going to order that, and I'll order the other one that's a little weak. On this, we need to set this to E2, back to off, and then we need to go 4 on our plate, 100 on our load. That's all the way over there, and that's in the off position. Number 7 is going to be our light that will illuminate. Let me change the view just a little. Alright, so let's go ahead and try it, see what happens. Alright, that's probably been long enough, we think. So let's go ahead and change our plate and see what magically happens. Okay, so that's normal. Alright, so no other lights. From what I understand, there's high voltage that's in this terminal cap. I don't know. Don't want to find out. Okay, here we go. You just double check. Okay, so our load has to be at 50. And 2, E2, TC, and 50. And number 7 should light up. So here we go. Okay. Cool. Now let's go ahead and switch over to the strength. So as you see there, it's probably about 45, so it's kind of weak, low. I mean, it works. And then we will put our plate back to number 4. Turn this up to 100,000. And turn this back on. And that looks to be about a whopping, I don't know, 28 or thereabout. A little weak. Let's go ahead and turn this off. And then we'll put the switch here on 5. And everything else is the same. Fantastic, that's completely weak. I know that I have 3 tubes to order. This will, in part 1, we'll come back. I'll order those tubes, and in part 2 we'll start the recap. We'll check out the components and recap. And then hopefully in part 3 we'll have our tubes and clean up the case. So, alright, thanks for watching. I do appreciate it. We will catch you in part number 2. See ya.